Now we're going to see conversion between polar and rectangular. Okay, so this is where you see polar, and then this is where you see rectangular coordinates, and these are the formula. This one is polar, and then to coordinate you get x and y for rectangular, and then these are just the answer, but this is the question, and this is just one example to give you the idea. We're going to convert the radius of 4 and then the angle of 60. So we're going to use which formula? We're going to use this formula that you see here. It's actually r cos of theta. This is how you can get this is the formula that you use here to find x, to find x, and then to find y we use r sinus of O. That's what you see here. So this is the formula we use in order to convert this one into a rectangular form. So we got the answer 2, and here we got the answer 2 times square root of 3. So that's what you see here. This is x, and then this is y that we just got here. Okay, now let's see the other way around, how we can move from rectangular to polar. So let's say this is what we got, 2 and negative 4 for x and y. We use this formula to go back to polar, s squared plus y squared square root. So this is where you get okay, so now x, you see this is where we have x, and then this is where you find negative 4, which is y. So this is how we represent them: to the power of 2, negative 4 squared to the power of 2, and then you get the answer is 2. And then for the angle, you take the arctangent of y x. Okay, so you can move back to get the angle. And for this question, since we're working with x and y, this is a 2D. Make sure that this is a 2D. Okay, so if it was 3D, we were going to have z into this formula, and then here we're going to have plus z somewhere there, and then this formula is going to be likely modify a bit. But anyway, this is when you work with 2D, you convert from polar to rectangular, and then from rectangular to polar.